All right, kids, we're looking at the last part of Unit 8, 8.7 through 8.12. 8.7 is today's lesson, and then we're done. So 8.12 is the end. We're looking at volumes with known cross sections that they give you a specific shape that it's been cut into, whether it be squares and rectangles, which is what this section is, or triangles and semicircles, which is the next section. It's how you're slicing this thing. And it's really hard to describe it until you see the pictures. So I would highly recommend that, just so you can get the visual for this, watch the first 4 minutes or so of the curriculum video. He's got a really cool app on there, and it shows you exactly what the picture looks like when you're slicing and you get squares. Basically what's happening is you get this cross section here, but it's really a square that stands up three-dimensionally. And had we had more time, we would probably have created these shapes ourselves, but we didn't have time for that this year. So I would watch just the first few minutes. Fast forward to where he has that going on with the visual for what this is, and it'll help you a lot to kind of get the gist. But nonetheless, here we go. A region is bounded by y equals x squared. Well, that's this guy. Equals x squared. And then the square root of x, that's the lower one. Right, we know what those graphs look like. And forms the base of a solid. For this solid, each cross section perpendicular to the x-axis is a square. So we need to know what axis we're looking at, and we need to know what shape we're doing. In this whole section, it's squares and rectangles. What's the volume of the solid? Well, I'm going to take you down to the box first, because here's what the deal is. Volume is the integral of area. Generally speaking, doesn't matter the shape, doesn't matter whether it's squares, rectangles, triangles, circles. If I want to figure out what the volume is, I have to find the area and integrate it. And so normally we have some kind of bounds. So it's the bounds going from A to B of the area of my function with respect to x, where A of x is the area of a cross section perpendicular to the x-axis in this case. Now, whatever it's perpendicular to is how you're making your representative rectangle. So in this case, I kind of drew it in here. If I'm perpendicular to the x-axis, this is my representative rectangle. Now again, I put that in there because it helps me to see what the top and the bottom is as I set this up. So first thing I have to do is think about, all right, what's the area of a square? Right, area of a square. What's the area formula? Formula is side squared. Side times side. Technically length times width, but they're the same thing. So side times side, side squared. In our case, what's a side? A side of my square is going to be the length of this, which is the top minus the bottom. That's why we did those sections before on areas. So the top of my function hits x squared. I'm sorry, the top of my function hits the square root of x, minus the bottom of the function hits the x squared. That's what a side would be. That would be one side for that square. So what's the area in my case? It's going to be that side squared, or the square root of x minus x squared squared. All right, let's set up the integral. The integral is for volume. I want to know the volume of this. I'm going to integrate the area. So the area is, we just said, the square root of x minus x squared squared. And what's it going between my x values of 0 and my x value of 1? And so then I go to, with respect to x, yep. Then I go to my handy dandy calculator and I calculate out what that integral would be. And it comes out to be 0.1285. I won't take the time to show you that. I think most of you have asked if you didn't know how to evaluate integrals on your calculator. In class, you've asked me how to do that. So if not, if you're still confused on it, when I see you again, I'll show you. Just ask. All right, here comes the next one. They're giving you formulas. If I take the cross section is a square the volume is the integral from a to b of the area of a square. Well, the area of a square is s squared. We just talked about that with respect to x, where s is f of x minus g of x. Or in our words, the top, wherever the top of your rectangle hits, minus the bottom of the rectangle. If they end up integrating the other way, remember integrating with respect to the y-axis, then that's going to change things around, flip things a little bit, and make it right minus left. But we saw that when we were doing areas previously, area between curves. If I'm talking for a rectangle, well, rectangles are the length times the width. With respect to x, where the width is f of x minus g of x, top minus bottom, and the height's usually given in the problem. So what they want to do is, let's go back to number 1, but now my square cross sections are taken perpendicular to the y-axis. Well, how does that change things up? It changes up my representative rectangle to be going this way. Right? This is going to be a right minus left situation, and I need to use y bounds. We talked about this in other sections too. So what's my area? I like to figure out what the area is first. Now remember, if it is perpendicular to the y-axis, I need to have x equals equations. So let me do that first. If I take, I'll do it kind of underneath. If I take y equals x squared, what does x equal? X equals the square root of y. If y equals the square root of x, then x equals y squared. So these are the two equations that I'm going to be using now with my right minus my left. The area is a square, so it's the side of the square. So what's the side? The right-hand side touches y squared. I'm sorry, the right-hand side touches the x squared, guys, so the square root of y is my first thing. And the left-hand side hits the square root of x graph, where the square root of x graph has a y that's y squared. Now, what do I do with that area? It's a square, it's side squared. And so once I have that set up, then I can set it into my integral formula. It's going to be the integral going, now y values, it happens to be 0 to 1 as well, but you're looking at the y's for this, 0 to 1. And we said our area is the square root of y minus y squared squared dy. And they didn't say we had to solve it, so that's it. You're good to go. Just set it up. All right, number 3. Now we have a different graph, the x cubed graph. We have y equals 0, that's the x-axis, and x equals 2, this vertical line that's there. Find the volume if the cross-section taken perpendicular to the x-axis forms a rectangle whose height is 2 times the width. Well, first thing I'm thinking of is I'm perpendicular to the x-axis. I'm going this way. All right, let's figure out the area of my rectangle. The area is length times width, generally speaking, right? This one says whose height, length, is 2 times the width. Well, if that's 2 times the width, that's this L piece, your height, times the width, equals 2w squared. Well, what's the width of, in our case? In our case, the width is your top minus your bottom, f of x minus g of x. So the top of the function is your cube. So we're going to have 2 times x cubed. And the bottom hits the x-axis where it's 0. So technically it's minus 0. And that is squared. 2 width squared. Here I go. So really, if I simplify it, it's 2x 2x to the 6th, right? Cubed and then squared. So let's put it into, find the volume of the cross section. So let's put it in the volume. I am going from x values of 0 to 2 of my area, 2x to the 6th, with respect to x. And again, we could go to the calculator and we could even antiderivative this one. It's relatively easy. But they did not ask me to, so I'm not going to do that. Find the volume, that's the represented. I think he just, for sake of time, ended up not doing it out in the calculator, but setting it up. So I don't have the answer for that one either. I just left it in this form. Next one, last one, find the volume if the cross sections taken perpendicular to the y-axis form a rectangle whose height is 6. Whose height is 6. First thing I know is I've got to change my equations. Really the only equation I have to change is the y equals x cubed guy. I need to solve him for x. So x is going to equal the cube root of y. Right, that's going to be a change. And now my area is, I have 6 times, whose height is 6. So 6 times whatever the width is. Now, this time I'm going this way with my representative rectangle. This one's a right minus a left. So to get that width, it's going to be 6 times, and then the right-hand side goes to 2, and the left-hand side hits the cubic, which is cube root of y. Length times width, okay? All right, let's put that into the volume formula, my integral. Integral, now I'm using y values. This coordinate up here is 2, 8. And so the y coordinate is 8. It goes from 0 to 8 of my area, 6 times 2 minus the cube root of y with respect to y. And then you go to your handy dandy calculator and figure that out. All right, so it's all about the area. Find the area first and then plug it into your integral, and it makes it way easier. Okay, we've got one to go more on the examples, and that'll be, then we'll look at a couple problems from the practice. So this one is a little different because they didn't give you a picture. You don't know what this thing looks like. But if I were to do this, I'm going to graph it over here. I'm going to go to my handy dandy calculator and I'm going to graph it out. Here's what it looks like. You have a happy parabola that is moved down 4. 1, 2, 3, 4. Happy parabola. X squared minus 4. And then you have another parabola actually that's unhappy, and this one has, it kind of looks like this. Now you can graph it and put it in your calculator and see. It actually goes through the origin up and then crosses over like this. They create a bounded region that's the base of a solid. So what I'm looking for is this part in here. All right, got it bounded, got it pictured. The solid has cross sections that are perpendicular to the x-axis. That means that my representative rectangle is going this way, vertically. And they form squares. Okay. So I'm going to put this together. I want to know what the area is, right? The area is, for a square, it's whatever the side is, and that side has to be squared. So it's the top minus the bottom. The top is my unhappy parabola, 2x minus x squared, and the bottom is my happy parabola, x squared minus 4. Now it is that side squared. Could you simplify it better? Sure, if you want to. It doesn't really matter much. If I were to do that, combine like terms, I have negative 2x squared. I have plus a 2x, and I have a negative 4, so plus 4. All right, and that's being squared. There's my area formula. So I set up my volume. My volume's going to be going from, ooh, I don't know where it's from, do I? So that puts me on a whole nother journey. I don't know what this x value is and this x value is. Is that bad English? So I need to find those so I know what my bounds are. So I'm going to go off to the side over here, and I'm going to set them equal to one another. X squared minus 4 equals 2x minus x squared. And I'm going to work my way through to see if I can figure out where they cross each other, where they would intersect. All right, so I'm going to have, bring everybody over here, 2x squared minus 2x minus 4 equals 0. Take a 2 out. X squared minus x minus 2. The 2 in front I don't care about. It gets ignored. X minus 2x plus 1 gives me x equals 2 and x equals negative 1. So now I know my bounds. Negative 1 and 2. Does it make sense? Yep, that looks like an x equals negative 1. This is about an x equals 2. Life is good. What's my area? My area is negative 2x squared plus 2x plus 4 squared with respect to x. There it is. Okay, so if they don't give you a picture, you want to make a picture. I'm looking at these practice problems. We're going to just do a couple. Number 5 is my choice, numbers 5 and 6. The graph goes the same for number 5 and for number 6. Same thing goes for 1 and 2 and 3 and 4. They've got their own individual graph. You want to, the bounded regions shown, find the volume of each solid based on the given cross-section, set up the integrals first, and then use a calculator to evaluate. So we are actually going to take the extra step and evaluate them on the calculator. I have square cross-sections perpendicular to the x-axis. That means I look like this. They kind of gave me my bounds. This is the coordinate E2. This is the coordinate here, 1, 0. And so I need to know my area of a square. What's the side of the square? Top minus bottom. 2 minus 2 ln of x. This is my 2 ln of x graph squared. There's the area. That's the side of the square. Now I can set up the integral. The integral of the x values, because I'm going around perpendicular to the x-axis, 1 in e of 2 minus 2 ln of x, quantity squared. I go to my handy-dandy calculator and I put that in there, and I get an answer of 1.746. But then for number 6, they want me to do cross-sections that are perpendicular to the y-axis. So now my representative rectangle goes the other way. It goes this way. It gets kind of confusing when you're using the same picture. But here's my right point. Here's my left point. I'll put dots there so we see that he's a little different. I need to have my equation y equals 2 ln of x solved for x. And this, my friends, goes back to stuff we learned in pre-calc with the loop-de-loop, where you do a swirl thing. So get the ln by itself. That means I'm dividing by 2. What's the invisible base that's here? I think I might change my color and show you. E, and then I do the loop. Whoop. That means that e to the y over 2 equals x. Remember those? I chose this one because I thought you might not. So there's my x equals. My area this time is still a square. So where's the right hit? The right hit's my e to the y over 2. Where's my left hit? 1. This value right here at 1. And so that is my area being squared. Let me move it over. And so I can set up my integral now. And my integral is going to be the integral. What are my y values? The lowest is 0. The highest is 2. 0 to 2. Of my area, e to the y over 2 minus 1, quantity squared dy. Toss that in the calculator. Remember, you can just put it in as x's if you want. It's probably easier to do that. Just make this x over 2 as you plug it in. It's going to give you the same answer. You get 1.516. Okay. There's that practice problem. Let me pick one more. Number 9. We'll do 2 more. So next one's number 9. We'll pick this guy. This one is looking at number 9. The square root of x graph. Well, that's the the outer one, and x over 3, that's the line. Their cross sections are perpendicular to the y-axis this time. In other words, I'm going right to left. And it's a rectangle whose height is 6. So it's going to be area is 6 times whatever my right minus my left is. So let's see what that's going to be. Now remember, I have to have my equations switched so that it's x equals. So I need to do that. I've got y equals the square root of x. That means x equals y squared. And I have y equals x over 3. That means that x equals 3y. So the right-hand side of this guy hits the line, which is 3y. And the left-hand side hits the square root of x, which is y squared. All right, you have your area, right? Length times width. Let's put it together. What are your y values for your bounds? Well, the lowest is this 0, 0. The highest is this guy, 9, 3. So it's going to be 0 to 3, my y values, of 6 times 3y minus y squared, dy. Could you, for the sake of putting it in your calculator, make it a little nicer and call it 18y minus 6y squared? Absolutely. Either way, when you plug it in, you get a pretty answer. It's 27. All right, here comes the last one. Last one. Let's do number 12. Number 12. The following curves create a bounded region. Each solid has cross sections perpendicular to the x-axis that are squares. Find the volume of each solid based on the given cross sections. Set up the integrals first and then use a calculator to evaluate. All right, so I'm looking at this guy, and I have to kind of be a little bit smart about this. If it's cross sections that are perpendicular to the x-axis, then I need to have it y equals. So I need to get this into a y equals form. Now, can you remember, and it's assumed that you do, remember what this is a picture of. X squared plus y squared is 100. If I were to draw the picture, because that's going to be helpful to me in the midst of trying to do this, it's actually a circle whose radius is 10. Do you remember that? X squared plus y squared means it's a center at the origin with a radius of 10. So this would be negative 10 here, this would be positive 10, and 10 up here, yada yada down the line. So the part that I'm looking at is the area inside the circle, right? The area that's bounded by this region. So here we go. If I were to color this. Look, we get to color in calculus. All right, there it is. I am perpendicular to the x-axis, which means that I am vertical with my representative rectangle. I am this way. I need this in a y equals. So y squared equals 100 minus x squared. So y equals plus or minus the square root of 100 minus x squared. The story with this guy is you need both the plus and minus because the plus is the top of the circle and the minus square root part is the bottom of the circle. You need both parts. So let's see. If I set up my area, I'm squares. So I am the top minus the bottom quantity squared. Top of it hits the positive square root of 100 minus x squared minus the bottom hits the negative square root of 100 minus x squared. And that whole thing's being squared. Area is side squared. The side is the top minus the bottom. So what does that really give me? Area is this square root plus another square root just like it gives me 2 of those square roots. That quantity is being squared. And again, there's several different ways that you can take this thing, and you could square out the 2. I guess we should do that. Let's square out the 2. That's going to give me 4. And when you square the square root, it gets rid of the root. So now you have 4 times 100 minus x squared. That's going to be a little bit nicer to put into your calculator. So your volume is going to be the integral x values going from negative 10 to 10 of 4 times 100 minus x squared with respect to x. Now that one, when you put it in the calculator, gives you a big number. Your answer is 5,333.33. Okay, that does it. That is section 8.7, and I will see you again for section 8.8. Let me know if you got any questions, and I'll see you in class.